This lesson is on geometric sequences. Let's start with what a geometric sequence is. In a geometric sequence, the ratio of any term to the previous term is constant. This constant ratio is called the common ratio. You'll remember when we did arithmetic sequences, how we wrote those. So that's going to be very similar to this rule for our geometric sequences. The rule is A sub n. Remember, n is whatever term you're looking for. Is A sub 1. This is the first term in the sequence. Times r with the exponent n minus 1. This r is going to be that new thing that we're calling that common ratio. Okay, and when these two variables sit next to each other, we remember they're being multiplied. You don't have to put a multiplication sign in there, just so that you do know. Okay? So example 1, tell whether the sequence is arithmetic or geometric. Then we're going to write the next term of the sequence. So remember, in arithmetic sequences, we were adding a constant number each time. And in geometric sequences, we're going to be multiplying because there's a multiplying thing going on with that common ratio. Okay? So example 1, we're going to look at, or A, I should say, 4 to 8 to 12 to 16 to 20. What are we doing each time? We're adding 4, and then 8 plus 4 is 12, plus 4 is 16, plus 4 is 20, and we need to find that next term, so the next term is going to be 24. Since we're adding each time, this is arithmetic. Okay, we're just adding that common ratio. All right, so example B, we're going from 2 to 6, then to 18, then to 54, and so on and so forth. Each time we're multiplying by what? How do you get from 2 to 6? And then to 18, we're multiplying by 3. Okay, so this calls for a geometric sequences. Okay, oh, and what is that next term? 162 times 3 is 486. Okay, and then in C, so this sequence isn't going up, but it's actually going down. I'm not subtracting anything. Technically, I'm dividing by 2, but if we're going to write it as a geometric sequence, the same thing as dividing by 2 is multiplying by 1/2. Okay. And then obviously 8 times 1/2 is 4, so that'll be the next term in our geometric sequence. And since we're multiplying, this is geometric. So basically, if we're adding to increase that common ratio, it's going to be arithmetic. But if we're multiplying, so like exponentially, we're calling the unit from the lesson from yesterday, we're exponentially growing there. So it's going to be geometric. Okay? So let's look at how to graph them. So in example 2, we're going to graph the geometric sequence below. That's 1/4 and then 1/2. And then you can see the rest. Well, we know that the first term is 1/4, the second term is 1/2, and so on and so forth. So we can set up a table to show our values of our first term is 1/4, our second term is 1/2, our third term is 1, our fourth term is 2, let's go all the way to the sixth term. our fifth term was 4, and then our sixth term was 8. Okay, and then all you have to do to graph this geometric sequence is to graph these as ordered pairs. So I'm going to 1, 1/4. I'm going to 2, 1/2. I'm going to 3, 1. Right 4, up 2. Right 5, up 4, and then right 6, 4, 5, 6, 7, up 8. That's your geometric sequence. It looks like an exponential formula or an exponential function. Okay? Look at example B. We're going to do the same thing there. Let's set up a table with your terms. Our first term was 27. How did I know there were no terms before that? Because there's no ellipses or no 3 dots before that. I know that's the very first term. Second term is 9. Third term is 3. Fourth term is 1. Fifth term is 1/3. Okay, and let's see what's happening each time here. I'm technically dividing by 3 or just multiplying by 1/3. So the sixth term, 1/3 times 1/3 is 1/9. Okay, so this we need to probably renumber our y-axis. Let's count by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, and then we can just go ahead and graph our points. I'm going from 1 to 27, 2 to 9, 3, 4, 1, 5, 1/3, and 6, 1/9. It's just getting very close to that x-axis there, and then you can connect your dots. Okay, that's graphing our geometric sequences, and then writing a rule. Ooh, let's do the code word. The code word for this lesson is iPhone, because I have my iPhone right here. So iPhone is the code word. Make sure you write that down. All right, so we're going to write a rule for the nth term in this geometric sequence. So whatever the term is that you're looking for. Don't forget, if you need to go back to refer to the rule, it was a sub n. So whatever term you're looking for is going to equal that first term, so a1 times r to the n minus 1 exponent. And we'll kind of see what that looks like here. And then it's going to ask us to find a7. So we're looking for the 7th term in this sequence. We'll fill out what you know. Okay, an is going to be, what is a1? That first term is 1. Okay, times, let's see, what's the common difference or what's happening each time here? We're going from 1 to -5 to +25 to -125. We're multiplying by -5 each time. So that's our common difference, is -5 to the n minus 1 exponent. All right, but now I know what my n is going to be. We said that we're looking for the 7th term. So a sub 7 is going to be 1 times -5 to the 7 minus 1 exponent. That's just a multiplication sign. Okay, so a7 is actually 1 times -5 to the 6th exponent. So that seventh term, a sub 7, is -5 times -5 times -5, 6 times. Remember, if it starts as a negative and it goes to an even exponent, it's going to end up being positive. And 5 to the 6th power is 15,625. Just multiplied by 1 is still 15,625. That's the 7th term in this sequence. All right, and example B. I'm still finding the 7th term, so let's figure out what our first term is and our common difference. So AN, well, the first term here is 9 times, what happens each time here from 9 to 18 to 36 to 72? I'm multiplying by 2 each time. Okay, so times 2 to the n minus 1 exponent. But I know what that n is going to be replaced with. We're looking for 7. So 9 times 2 to the 7 minus 1 exponent, which is really just 9 times 2 to the 6th. Okay. So we're going to do 2 to the 6th first because exponents comes before multiplication. So 2 to the 6th and then times 9 is 576. I had to do this first because it comes first in PEMDAS in the order of operations. And that's the 7th term in the sequence. Okay. Make sure that you get this glued in on your right-hand page on 115. If you have any questions, feel free to shoot me an email or send me a text. Go ahead and you can also complete that left-hand page, but don't glue it in until I've checked for understanding tomorrow in class.